I want to take a look at the new Share Your Work for this week, week 2 in quantitative literacy. And it's about two things. One, the idea of slope, a rate of change. And then in this case, we're going to take a look at COVID cases in Oregon counties over the past year and see what's going on, what can we predict, just to play. So I have a spreadsheet here I link to, and when you click that link, it'll open up the sheet. And depending on how you use Google Apps, so I'm signed into Google right now, so there's a little picture of me in the corner saying I'm signed in. Sometimes on the account there might be like your initial up there for like your first or last name to indicate you're signed in, or there'll be a sign up or sign in button up there if you're not already signed in. If you're not a Google user, then you'll have to download this as an Excel file and work with it in Excel on your computer. And what I'm going to do right now, it doesn't matter whether you're in Google Sheets or Excel. So you decide, either download it to Excel or log into your Google account and make a copy and then rename it. So, maybe I'll call it something like Parker's Oregon COVID stuff. And you could decide where to put it in your drive or just put it in your drive. So that makes a new version of the file that you can edit. Okay, so I've got my version that I can edit here. So now I can type stuff in here, like stuff. All right, so let's take a look at the requirements for this here. Blow that up a little bit. So again, you should solve these problems on your own. So if you normally get help by it with a tutor, I appreciate it if for this problem you would just try to do it by yourself. And I have that spreadsheet I just went to, and we want to use the data to find a linear model. And we've been talking about linear models in section 3.2 and 3.3. I'll talk about it again in a second. In this case, for an Oregon county of your choice. So that spreadsheet's got all of the Oregon counties here in addition to the total for Oregon. So you need to pick one of those counties, and whichever one you pick, it's fine with me. So you decide. And let's see, what else do we have? We got the total number in that county for a given month. And the months there I have are for May and August, if you look back for that. And I mentioned it up here, May and August. And you can see these were the counts on May 11th and the counts on August 11th. So it's not the, the full count up to the end of the month, but I'm going to make believe it is. But those are the exact dates I found those numbers, because I've been keeping track of how COVID's been moving along throughout the county here, the town, the country, the world. It's interesting. It's frightening, but interesting. Anyway, so our X values are going to be the number of months after May, right? So June is right after May, so June would be month 1, right? 1 month later. And then what's after June? July. July would be month 2. August would be month 3, and so on. The Y value for what we're going to calculate is just the number of COVID cases in your county in that future month. So if I plugged 1 into my equation, that means I'm trying to calculate June. If I plug 2 in, I'm trying to calculate July. And I'll write that down in a table. We're going to have to find the slope, and we've played only a little bit with slope so far, so this part's a little challenging, but I describe exactly how to do it. You're just going to find the difference between the numbers for August and May, divide by 3, because they're 3 months apart. That's our slope. And the y-intercept is going to be the May amount, because that's what I'm starting at. And so we're going to build this equation right here based on that information. And ultimately, what we want to do is say, hey, can we predict what's going on with January based on the May and August numbers? And then we'll look to see what the January numbers are and compare just for fun. Okay? And so your goal is to come up with your equation, that's the linear model, to do a calculation for January based on your equation here, and then do some of this in a spreadsheet. Okay, so some of it I'm going to write on paper, some of it's going to be in a spreadsheet. So let's give it a try here. All right, so this is my Share Your Work week 2. And I might as well put my name on here because I'm going to turn this in. Right, and often I write this on a regular piece of paper, but I got to do it digitally right now so you can see what I'm doing in the video. And I'm going to choose the Oregon County Oregon County of Morwenaville. And so if I look back at the spreadsheet, I want to get the data for Morwenaville. That's my county of choice. Where did that go? That's here, I think. And there. And there's Morwenaville. I highlighted it because that's my county. And it looks like in May there were 90 total cases. That was like all of the cases from when we started finding people with COVID up through that date. And then in August, there was a total, not just for August, right? This is the total of all cases in that county. There were 573. So 90, 573. That needs to go in my notes. So I'm going to put this in a table, and I'm going to write the table like this. I'm going to have a column for the month, and then a column for X, and then a column for the total cases, total COVID-19 cases. And so in the month of May, that's month 0, my county had 90 cases. And then, like if I skip on down, 1, 2, 3, May, I'm skipping June, I'm skipping July, and I'm going straight to August in my data, because that's all I provided. So that's 3 months later, there were 573. Let's make sure I wrote those numbers down correctly. Yep, 573. Okay. So the things I need to calculate here, I want to find out what's the rate of change here. So a big idea this week is the idea of slope. Slope is what we call a rate of change. And to find slope, let's see, green maybe, I need to take what we call the independent variable. That's the result I'm counting here. So that's the change in COVID cases. I'm just going to say change in cases divided by the change in your other variable, which is months. So in this case, it's going to be change in months. Okay, so I can clearly see 3 months have gone by, right, from May to August. I can count that on my fingers. The 90 to 573, I think I'll actually do a calculation to double check that instead of just doing it in my head. So over here, I could calculate that just by going equals, click on the second number here, and then subtract the first number. And computer says, and no, I don't want to autofill, that 573 minus 90 is 483. Okay, so let's put that in our notes. $483. And then I should continue to divide by 3. So I'm going to adjust that because I really want the slope, the rate of change, not just the difference. So back to this formula, I'm going to delete it and do it again. I'm going to go equals. I'm going to put the subtraction in parentheses, close the parentheses, then I can divide by the 3 months, and I got to have the parentheses there. Okay, so if there's 483 over 3 months, that's about 161 per month. And sometimes when you divide by 3, you get like crazy numbers. So let's just check on another calculator. If we take 100 divided by 3, like maybe your difference was 100, then I get 33.333333. And usually what I do in a situation like that is I look at the data and I go one more decimal place than the data. So if I zoom in on this, you can see all my data is whole numbers. So if I did have to round, then I would go one decimal place more than the data. So then I would say here, the letter we use for slope is M. I would say my slope is 161.0. For that other example I had, like if your change was 100 over 3 months, you would have 33.3. And again, what do these numbers mean? The 483 is cases and the 3 is months. So this number means cases per month. Okay, sometimes we might write it as cases / month, right? Cases per month. Kind of like, miles per hour, miles divided by hours. It doesn't matter that I have the June and July data. I don't really need it. So for my formula, new page, I'm trying to find something like y equals mx plus b, and I explained in the description of the project how to get that m, and I just did an example of it. And the b, that's what we call the initial value. And initial value is the starting value, and we started counting for this particular project in May. Oops, try that again. In May. And so it's the May amount that goes there. So for me, for Morwenaville, I'm getting that Y, the number of COVID cases in some month, is going to be 161 times X plus I started with 90. So to check that if it works out, just to double check I did that right, I'm going to check August because I know August. In August, X would be 3 because it's 3 months after May. So if I calculate what is 161 times 3 plus 90, get a calculator for that. So let's blow that up a little. 161 times 3 plus 90, I get 573, which is that number in my spreadsheet. So what does that mean? It means I wrote the right slope down and I wrote the right y-intercept. And at the top of this document, it says put your slope calculation in column D. So that's what I did here. Now to calculate for January, I got to figure out what month January is. And so for me to do that, I got to count on my fingers. So let's see. After May is what? June, July, August, September, October, November, December, January. So that's 8 months later. So for January, I'm just going to make a note up here, x equals 8. So I want to plug in 8 into my equation, and I can do that right in my spreadsheet here. So I'm just going to go to that line on my spreadsheet. I'm going to type equals. I'm going to use my slope. You're going to use your slope. So I could do that by either just clicking on it there, multiplying it by 8, because x is 8, and then adding on the starting value, which is that 90 right there, which I can either click on it or type it and hit enter. And I don't want to fill it. Thank you, Google, for asking. So I get there should be 1,378 cases if COVID continues to grow at the same rate it was from May to August. So was it growing at the same rate? Okay, so I'm just going to double check that calculation on my paper, make sure I got it right. All right, so remember my equation for Morwenaville, 161x plus 90. I want January 2021, which I figured was 8 months later. So then for that, it's 161 times 8 plus 90. And I'll check with my other scientific calculator to make sure I did it right on the spreadsheet. If you're new to a spreadsheet, it's a good idea to confirm with a calculator. So 161 times 8 this time, plus the initial number of cases in May of 90, 1,378. Yeah, I got the same number there, right? So that's my January number. So again, assuming that, so I guess I need to write a sentence, right? Double check. January prediction with a sentence. Oh, okay, back to my notebook, right? Writing about quantitative literacy. Switch color. So how about something like assuming COVID-19 cases continue to increase at the same rate. COVID-19 cases increase at the same rate as May through August. then I'm making a prediction. So I'm going to say I predict about, what was that, 1,300, sorry, calculator please. Where'd you go? 1,378 cases. I predict 1,378 cases total by January 2021. How'd I do? I stated what the number means and I put a little context to it. That's a pretty good sentence. So then what I would submit here is I would take a picture of my paper here, which I have a couple pages of paper of work trying to figure this out. So I'm going to submit that. And then I'm also going to submit my spreadsheet here because it's got my calculation in it. So let's look at the project again, double check. So I got a linear model. I wrote that down in my notes. Let's see. So I stated it here. I stated it again right here. Okay, so there's my linear model. Maybe I could be even more explicit by saying Moore-Wennerville linear model. Oops. And circle it. I don't know if you're a messy writer. Sometimes I have to rewrite my notes a couple times before I allow other humans to look at them. All right, let's see. So I got the linear model, I got my prediction, I got my spreadsheet, and I already put the labels in there for you, so there really wasn't much more to do aside from maybe I highlighted the month I picked, and there's my slope and my prediction there. Just for fun, a few days ago I looked up what the counties in Oregon had, and so for Moore-Wennerville there were 3,412. Holy crap. So it looks like cases were growing way faster in Moore-Wennerville total since August than they were May through August. All right, craziness. Now, note here, I made up Moore-Wennerville. There is no such place in Oregon. I have a cat named Moore-Wenner, so I did Moore-Wennerville there. And the numbers I actually used, Moore-Wennerville is actually the average of all of the other counties. So on average, in Oregon counties, it turns out COVID has grown way faster since August than it was in May through August, okay? And you know, summer we were outside more, that kind of makes sense. So it's not growing in a straight line, it's growing faster than a straight line. Kind of frightening. All right, take care, that's it for now. Do good math. See you in the near future.